Hello, stat students. Welcome to section 2.3a, other types of graphs. So we spent time making histograms so the data is organized. Sorry, we spent time making frequency distributions, and then we've made histograms, ogives, frequency polygons, all those kinds of things. Now we've got three more types of graphs to talk about. The first is a bar graph. We are making a distinction between bar graphs and histograms because bar graphs use vertical or horizontal bars. We know that's not the case with a histogram. However, we're still representing frequencies. These also can be used to compare data, compound bar graphs. You know, what's the unemployment and poverty and other things in 1900 versus 2000. So we would have bars representing each one of them, typically color-coded. And this is typically used for qualitative data. So the other things that we've been doing, the other graphs and charts we've been doing have typically been quantitative. So this kind of leads us into that qualitative realm. So we've got sales for fast food franchises. The data gives the worldwide sales in billions of dollars for fast food franchises for a specific year. Create a horizontal and a vertical bar graph. I think we can just do one. We're so accustomed to vertical. Let's make a horizontal just for kicks. So the first thing you need to do, I don't know what the first thing you need to do. The first thing that you need to do is to label your axes. I'll just write that in. You need to decide which one's your X and your Y. If we are going to do a horizontal, that means that we are going to have our frequency across the x-axis and our labels, our qualitative data labels, or our restaurants, up the y-axis. So you've got two choices. Your, I'll call it your class and frequency. And then you're just going to draw your bars corresponding to your data. I really thought I had that in there. Draw bars. We'll keep it simple and sweet. So I've got this. If we are going to make a horizontal bar graph, again, our bars are going to be horizontal, not vertical. So that means my frequencies are going across the x-axis. I go from, 9.2 up to 37 billion. So let's say here's 10 billion. We'll count by fives. 20, 30, 40. So there's 15. So then up the side, it's not like our typical scale because it is qualitative data. So I would just start with Burger King and Dunkin', I'll call it DD, McDonald's, Starbucks, Subway, Taco Bell, and Wendy's. I need to make my axis a little longer. I'm going to go right across my directions. And then we go from there. Draw the bars. Let me hit a quick pause. You draw your bars. I don't need to take all your time doing that. I'll be right. So I forgot to mention before I hit pause that you should not connect your bars. Bar graphs are not typically connected because it's qualitative data. Think about the labels. We don't have any way to connect them. And again, I don't know about you, but I always feel like it looks weird as a horizontal bar graph. We're so accustomed to vertical. So how do histograms differ from bar graphs? Well, I mean, they're still bars, right? It's qualitative versus quantitative. Bar graphs can be horizontal or vertical. Bar graphs have gaps between the bars. So let's do this. Let's see. This has gaps, no gaps. This is quantitative data. This is typically qualitative data. This is always vertical. This is vertical or horizontal. Just want to make those distinctions between those things. Otherwise, I feel like probably everybody has a pretty good grasp of bar graphs. So Pareto charts are something new. Pareto charts are just a modified bar graph. So it's the frequency distribution, just like a bar graph. The frequencies are displayed by the heights of verticals. So please note, it has to be vertical. But here's the key difference. It is arranged from largest to smallest. And there are no gaps. So I don't feel like I need to make a Pareto chart. Do you want me to make one for this? We're just going to rearrange all of our data. It must be vertical. So I would have my setup like this. And I would have my qualitative, my classes along the bottom. The thing is you have to look at arranging from largest to smallest. So McDonald's would go first. And I think, was it Wendy's? Dunkin'. Dunkin' went last. So here's my largest. And here's my smallest. Everything else gets arranged in between in order from smallest to largest. What was it again? I can't remember. Dunkin', right? I'll call it DD. I'm old-fashioned Dunkin' Donuts. So all of our bars would be descending. I don't think I need to do that. I think I have a question. Do I have a question? Nope, I don't even have a question. Oh. So practice. Construct a Pareto chart. So we use vertical bars. We put the categories in order. We put no gaps in between them. Did I put gaps when I did that? Nope, I didn't do a second example. So I'd have another one going like that, but it's probably way shorter, right? Down in that range. I make the bars the same width, which I'm going to do in a bar graph as well. I didn't mention that, but I just feel like I assumed you knew that. And as always, our frequency must be equal in size. The advantage of using a Pareto chart over a simple bar graph is simply, I think it's probably easier to read maybe, or easier to identify because you are putting them in order from highest to lowest. So I'll put easy to read. Please keep in mind, no gaps. So those are Pareto charts. I don't have to make the whole thing, I don't think, because I feel like everybody's got that. So last but not least, a time series graph. This is a graph that represents data over a specific period of time. This is a good one. Time always goes with this. Remember, maybe you remember, these always look like, these always look the same. They're always dots with our connected segments. So if we are going to do a time series graph for this percent of cigarette smokers, step 1 is to draw and label your X and Y axes. Your X is going to be your years. Your Y is going to be your frequency. Second thing, oh, I already said that. Boy, I got ahead of myself. Give yourself an X-axis for years, your Y-axis for time. Oh, Y-axis for your frequency over time, sorry. Step 3, plot each point. And step 4, connect them with line segments, not curves. Connecting your adjacent points. You do not make it a frequency polygon. Don't connect at the origin and at the end. Just draw what you got there. So the data show the percentage of U.S. adults who smoke. Draw and analyze a time series graph for the data. I wish I had a 2020 data in there. If I'm going too fast, hopefully you realize that you can always hit pause. So when I make my graph, my years go across the bottom. And my frequency or my percentages go across the top. You want to just watch how you do those. Remember, if you're going to skip a few, you need to still be consistent with your labeling. So if it starts way up high, you can do that little break that we do in a graph. This one you don't really need to because we've got a high of, what, 37 and a low of 19. So I'll go up here to 40, 20, 10. So in 1970, everybody gets the idea. I'm going to just take a quick minute, put that together, and then I'm going to put out my pre-made graph. So on my pre-made graph, my x-axis is still my years. My y-axis is counting by fives, which I did dash it by fives. I only labeled by tens. So there is my time series graph. I should have some better dots here. You'll have better dots at yours. And then when it says to analyze that graph, basically the analysis, it looks to me from 1970 to 2020, the percentage of US adults who smoke has been decreasing at a pretty steady rate. That would be an analysis. Hopefully you feel comfortable with that, at least comfortable enough that we don't need to make an amount spent on Valentine's Day. I think you're probably good on that. So that is wrapping up section 2.3a. I think we're good there. If you've got any questions, please let me know. Otherwise, thanks for sticking around.